Hi, welcome to the next TA training session, Arduino lesson number 2, Spaceship Interface. Today, what we're going to be doing is instead of using one LED light, we're going to be using 3 LED lights to actually make a really cool flickering motion with the button. We'll also be using code today to learn about conditionals, variables, and Boolean values in C++. We're also going to be learning how to detect electrical flow in our circuit. Let's take a look at what a standard Arduino breadboard might look like. So either in Tinkercad or in person, you're going to set up your breadboard and your Arduino. So if you go into Arduino here, click the breadboard option. You can also scroll out. You'll see that there are 2 extra wires in here. Make sure to delete these 2 wires. This is going to be the start of our code, or like the base. Now what we want to do is actually set up our components. We want to have 3 LEDs and a button set up in this formation. It doesn't have to be exact, but you'll have to change the wiring a bit later on. Let's do that now. I'm going to go into All, and I can search up our LED. And what I'm going to do is I'm actually going to zoom in a bit so that I can get the holes in properly. So I'll put 1 LED there, leave 2 spaces, another LED, and my final LED as well. I'm also going to attach a button to this as well, which we're going to be using to control our LEDs. Make sure that one of the LEDs is green. Your students can change their LEDs to whatever color they'd like, but for this demonstration, I'm going to be using 2 red LEDs, 1 green LED. After you're done this step, you're going to be connecting the cables from the Arduino to the breadboard. But notice what we did last time was we actually connected cables within the breadboard. However, this time we're going to be connecting cables from our Arduino to the breadboard itself. So you see D3 here. I'm going to connect it to my green switch, as you can see in the diagram. And from pin number 4, I'm going to connect it to here. And from pin number 5, I'll connect it to here. Notice how all of my wires are going to the cathode, not the anode. So make sure it's on the left side and not the right side. So this is actually where the electrical signal is being outputted. After you're done that, we can head on to the next step. Now we're going to be actually setting up our buttons. So from pin number 2, what we're going to do is we're going to put that on our input. And from and then what we're going to do is from the button output, I'm just going to link this back to the negative side. Actually to the positive side, I'm sorry. So from this to the positive side, and what I'm going to do is I'm also going to get a resistor to resist the electrical flow. But this time I'm going to connect the resistor to the positive side. Now I'll also add some resistors to our buttons as well. So if you see here, the electricity will be going through our resistors. So I have 3 resistors like here. Now our initial circuit board is complete. Let me explain how this circuit actually works. As we've talked about in the last lesson, the power is originally going to come from the 5V, so the voltage, and remember what voltage was, or like the amount of electricity. It's going to come all the way up to the positive side. And notice there are metal strips running under here, so electricity is actually being conducted. The electricity will go through this resistor and all the way up to this button. But notice, if we actually press this button, we're actually going to be releasing the electricity. What happens next is, oops, I'm just going to move this right up there. What actually happens is the electricity will go into the resistor, and it'll also travel back through our cable back into our Arduino rather than going through the negative sign again. Let's talk about what a variable is now. This is what we're going to be using today for our code, and it is important that you master the concepts of variable, especially when you're teaching your students. A variable is something that keeps track of something, or it's another name for an object. If I told you what 12 was, you wouldn't have any idea what that number actually represented. What we can do in code, however, is to name that data or that piece of information. So if I say that age is equal to 12, what that means is I'm setting up a new variable called age. So age is the name of the variable, and what this variable will store is 12. It's very similar to what variables are in math, except that in coding we can name variables whatever we want. As you'll see down here, cout age, what this means is to print age onto the screen. And let's take a look at what data types are. As you can see from int age is 12, we can see that 12 is a number. But you'll see that I've bolded this part called int. What int actually stands for is an integer. In school, you'll probably have learned what an integer is. It's like a whole number. For example, -1, -2, -1, 12, 5. These are all examples of integers. What about floating points though? Well, floating points are numbers with decimals, so maybe like 2.5 or -2.5. But notice how 3.0 would still be a floating point just because of that decimal point. A string is a very simple word like hello. A character represents just any simple character, maybe like A. It's only one letter of the English alphabet. In C++, we also have something called global versus local variables. A global variable is a variable that can be used anywhere in the code. So if I just say that my age is 12, all the pieces of my code is going to know what age is. But a local variable is a variable that can only be used in specific parts of my code, which we'll talk about in later lessons. Now let's actually write some code. Let's set up a new variable called int switch state. So if you press code and then text, we're going to see some code like this. Let's erase the top 2 lines. What I'm going to write is the exact same code as in the PowerPoint. Int switch state is equal to 0 with a semicolon. What this code will do is that it's setting up a new variable called switch state, which will represent the state of our button. So whether the button has been pressed or not. In void setup, we're going to talk about void setup and void loop a bit later, but you can just delete all the code in here. But for now, know that int switch state is a global variable because we've declared the variable or set up the variable outside of these 2 code blocks. So if we set up any variables just on its own, it'll automatically be a global variable. However, let's say that I set up a new variable here called x is equal to 1. This, on the other hand, will be a local variable that can only be used in setup and nowhere else. Let's talk about what void loop and setup actually does though. Void setup is the code that runs when you first start the program. So if I actually press start simulation, void setup will only run once. But void loop, on the other hand, is a code that keeps on running. So let's say that I was checking if button pressed or something. So all I'm going to be doing is I'm going to be checking if the button is pressed. If this is true, what I'm going to do is I'm going to do something, right? What my code will do is it'll continuously check, so forever check if my button is pressed or not. And we're going to be using that concept a bit later. Let's type this into void setup now. Remember to keep int switch state, so do not delete this code. So in void setup, what I'm going to do is I'm going to set it to pin mode. Pin mode 3 output, pin mode 4 output. You can actually pause on my screen here so that you can type out your code yourself. I will simply be copy pasting my code. I'll explain what this code means right now. So what pin mode does, it actually sets up these pins. So I'm just going to hide my code for now. You can see these little numbers here, 2, 3, 4, 5, and 6. These are what we actually call pins in Arduino. So you can see that pin 2 is connected to the button, pin 3, 4, and 5 are connected to the LEDs. So what I'm doing when I actually set up the pin mode is I'm telling my code, okay, number 3 is going to be used for output. So I'm going to be using these 3 pins to give my LEDs some signal or some instruction. What number 2 is going to do though is it's going to take in some input. So if I press this button, that's an input because the user is clicking on the button, so that can be classified as an input. So this code will only run once, and we only need it for it to run once so that our code knows what each of these different pins represent. Let's take a look at the next slide. Void loop, on the other hand, as I've said before, will continuously run. We're going to set up a new variable, or actually an old variable, but we're just going to set up a new value to that variable. So I'm going to say that switch state, and remember switch state was initially 0, is going to be digital read 2. What this will do is, remember, we set up pin number 2 as input, but we have to actually get something from that input. Digital read will actually allow us to get input from our button. Let's see how we can use that input later on. Switch state, or our variable, will be high if the button is not pressed, and low when the button is pressed. You'll see a bit more on what I mean about this later. Let's check if the button is pressed or not. So as I've said before, we can use something called a conditional statement. What a conditional statement does, it checks something. Is 1 plus 1 2? Yes, it is. So it's going to run some code. Or I can also say this. If I touch the wall, then I will stop walking towards the wall. Or if my YouTube video has ended, I will play a different YouTube video. Those are all examples of what conditional statements are. But this time, I'm going to use a conditional statement or an if statement to check whether a button has been pressed or not. So if switch state, and make sure to include these brackets, they're really important. Switch state is equal to low, and the double equal sign is really important as well. If that is low, what I'm going to do is I'll talk about that a bit later. But what this code basically means is I'm checking right now if our button has been pressed or not. If switch state is low, that means that the button has been pressed. If it is not, or else, so if you clean your room or else, right? So we have that else statement here. And let's actually get our circuit to do something. If it is pressed, what I want to do is I want to make the LEDs flicker. If it is pressed, what I'm going to do, digital read. I'm going to be doing digital read 3 high, and I will be doing digital read 4 low, digital read 5 low. When I do this, I'm actually sending a signal to pin number 3, 4, and 5. So to pin number 3, what I'm doing is, okay, I want you to turn off, or actually, sorry, on. So let's see what happens. I'm just going to remove this one, and I'm going to run the code. Oop, start simulation. Oh, I forgot end bracket there. Sorry about that. Oh, digital write, sorry. Digital write. So make sure it's right, digital write. And if I start simulation, what it's going to do is you're going to see these two lights are actually on, but the green one isn't. So number 3, we set it to high, but think of it the opposite way. If we set something to high, it'll be off. If we set something to low, it'll be on. So pin number 4 and 5, they're actually on right now. But pin number 3 though, or the one that's connected to our green LED, is right now off. But what if we press the button? What should happen? So let's write something else. If our button hasn't been pressed, or if our button has been pressed actually, what we're going to do is we're going to make it flicker. So we're going to write digital write, and I'm just going to copy paste 4 of this and delay 250. And what delay does, it actually delays the code, so it makes it wait actually. And then I'm going to have 2 more digital writes down here as well. So I want to have pin number 3, 4, 5 and pin number 4 and 5. But you can actually customize this to whatever you want. So have your students play around with this code. So if I set up my code the way I did right now and just start the simulation, look at what happens. These 2 LEDs are on, but when I press the button, you'll see how that red LED on the very left is actually kind of flickering there. So you can actually get your students to do whatever they want with this code. Try to get them to do a challenge. Or if a student is done early, maybe you can add a 4th LED. Amazing work today. I hope that you had a lot of fun in this video, and I'll see you in the next one.